Today we are going to be talking about some similar figures. So we have some 3 words of vocabulary today. The first one, well, first off, what is a similar figure? A similar figure is a figure that has the same shape but not the same size. So same shape, not the same size. So for example, these are supposed to be 2 squares. We have one square that is that is the same shape as the smaller square, but it's not the same size. Thus, these two would be an example of similar figures. Corresponding parts. Corresponding parts are the angles and sides that are the same on similar figures. So let's go back up to these 2 examples. You might see them denoted as if there's a mark on both sides. This is basically stating wherever the side that has one mark, these are the same. So this shows 2 marks. So wherever there are 2 marks, those are the same. So that's basically how you can see corresponding sides. With corresponding angles, they could have it with a mark as well. That would denote that these are the corresponding angles. Now, congruent, you might have heard of the term before. That's where with the line segments or angles that have the same measure. So in this example of these 2 triangles, just hand-drawn triangles, these are congruent because these sides are the same and the angles are the same. Thus, these figures are congruent. So when you're working with similar figures, basically most of the time you're going to be trying to find a missing piece of information. So when you're trying to do that, I highly recommend setting up a proportion. You need to be careful when you're setting up the proportion. So remember, it's basically we're going to create 2 fractions that are equal to each other. In the numerator, I want you to put all of the information for figure 1. In the denominator, you're going to put all of the information for figure 2. So I'm going to use the red, as figure 1. And the blue is the smaller one is figure 2. So in this, I'm trying to find what x is. What's the length of this side? These are similar figures. So if I'm just going to focus on the sides first. So on the left side, I have 2. Then I want to find on figure 2 for this denominator, what's the corresponding side for 2 in the smaller one. So the corresponding side for this over here is 1. So I'll put 1 here. Now remember, in the numerator over here, we need everything that's in figure 1. So we have a 6. Now the corresponding side for 6 is x. Now all we have to do is solve for x. We could do it 2 different ways. Remember, it's either the butterfly method or the multiplication and division method that I've taught you. So if we do the multiplication or division method, how many times does 2 go into 6? You can multiply that by 3. So whatever you do to the numerator, you have to do to the denominator. Multiply it by 3. So in this case, x is equal to 3. But please be careful when you're setting up this proportion. So now we are trying to find the missing measure. This is an example, so please write this down. We're trying to solve for x. So I'm going to use the red triangle as figure 1, blue triangle as figure 2. So if we write down the side of 12, what's the corresponding side for figure 2? The corresponding side is 4. Now we have, remember we're still sticking with figure 1, so if we already used 12, we need to put x up here. The corresponding side that goes with x into the blue one is 6. Now from this, we can use the butterfly method. So if we do the butterfly method, when we do 6 times 12, that is equal to 72. 4 times x, that's equal to 4x. If we have, go over to the right, if we have 4x is equal to 72, to get x by itself, you would divide by 4. When we do that, x is equal to 18. So you can do it the butterfly method, but there's also another way that you can look at it. If you realize we have the similar size of 12 and down to 4. How many times can 4 go into 12? 4 can go into 12 3 times. So we know that 6 must go into whatever x is 3 times. So if we do 6 times 3, that's also the same as 18. So you can look at it different ways. If it helps to set it up with the butterfly method, go right on ahead. Go do that. If you can just automatically just see that it's going to be 18 and you see that 4 times 3 is 12, and so 6 times whatever, or so 6 times 3 must be x, then you can solve it that way as well. So either way is perfectly fine. So now what I want you to do is your turn. I want you to pause the video, try to solve this, solve for x, unpause the video when you're ready to see what I've done. Alright, so there's 2 different ways that I'm going to show you. The first way is the butterfly method, so I'm just going to use figure 1 up top and figure 2 on the bottom. So if we have 5 in figure 1, the corresponding side for 5 is 30. So now I'm going to stick with figure 1 and place it in for x. The corresponding side and the larger one is 24. So you could just do the butterfly method. This might take a little bit longer. Where 5 times 24 is equal to 120. 30 times x is equal to 30x. Let's rewrite it over here. Now to solve x, you'd have to divide by 30. In this case, x is equal to 4. So, if you can do the butterfly method this way, perfectly fine. Or you could just look at it logically another way. So we have 5, and that is getting larger up to 30. So how many times could 5 go into 30? 5 goes into 30 6 times. So we know something times 24 must go into it 6 times. So what we could do is just divide 24 by 6, and then that's where the 4 could come from. Either way, perfectly fine. I don't care how you solve it, just make sure that you're solving it correctly. Time for a quick review. When you are working with similar figures, always remember to set up a proportion. It'll be the easier way for you. And if you do that, make sure you set it up correctly. Please be careful when you set it up.